Now let me see the functioning of the combined power generation. So this is the line diagram of combined power generation. Here you can see the combination of gas turbine power plant and the thermal power plant, or you can say the steam power plant. Okay. Now the bottom portion is said to be what? Gas turbine power plant. Can you see what are the major devices in gas turbine power plant? Compressor, combustor and turbine. Similarly, what are the components you can see in the steam power plant? So this one is said to be heat recovery steam generator. Is nothing but boiler, and then the superheated steam go and hit the turbine, that is steam turbine. From the steam turbine the steam passes to the condenser. From the condenser it goes to the cooling tower. Again the cold water from the condenser goes to the boiler through water pump. So the combined power generation is a combination of both gas turbine power plant and steam turbine power plant, or you can say steam power plant. Now let us see how it functioning, or the working principle of combined power generation. Okay, now the inlet air, or you can say the fresh air from the atmosphere passes through the compressor. The fresh air from the atmosphere passes through the compressor. It gets compressed. Then where it goes? It goes to the fuel combustor, or you can say the combustion chamber. Okay, from there what happened? The hot gases will come from the combustion chamber. We're going to get very high pressure and very high temperature burnt gas or hot gas. It passes through the turbine. It go and hit the turbine blades. So what happened? The turbine going to rotate at very high speed. Yes, it going to rotate the generator, and we're going to get the power, or you can say the electricity. The remaining 50% of the power has been used to run the compressor. So these and all already we studied in our gas turbine power plant. Now what happened to the exhaust of the turbine? It directly go to the heat recovery steam generator. Heat recovery steam generator is nothing but what? One of the boiler. Now you can see the one side the water is coming to the HRSG, heat recovery steam generator. The other side what happened? The burnt gases from the, or you can say the used gases, leave from the turbine. Now it go and heat the inlet water. Okay, so it's like a heat exchanger. Now this one will act as the heat exchanger. What happens? One side the water is coming, the other side the hot gases is going out. Now what happened? It going to the hot gases leaves from the turbine, going to heat the water inside the steam generator. Very good. Now what happened? The always heat has a tendency to move from higher temperature to lower temperature. So the cold water which is coming to the HRSG, heat recover steam generator, going to gain the heat, and then it becomes what? Superheated steam. That steam is go and hit the steam turbine. Now what happened? I'm going to get the power from that. The power has been generated from the steam turbine, and then again that steam will passes through the condenser. The exhaust gases goes to the atmosphere. Okay, see that exhaust gases goes to the atmosphere. Only the steam is passes through the turbine, that is superheated steam will go and hit the turbine blades. The turbine going to rotate, the power will be generated, and then the used steam goes to the condenser, and it goes to the cooling tower for what? That a phase change. From the superheated steam it converted into water. Again from the condenser it come back to the HRSG, heat recover steam generator, by pumping the water to the HRSG from the condenser. Now the cycle continues. Okay. So the combination of both gas turbine power plant and the steam power plant is said to be gases is leaving from the what is that gas turbine. Okay, so we are we are bringing out the maximum efficiency of the power plant. Okay, we are getting the maximum efficiency of the power plant. So this is nothing but combined power generation. Now we are going to see the functioning of the combined power generation. One second. The combined cycle power plant or combined cycle gas turbine, a gas turbine generator generates electricity and waste heat is used to make steam to generate additional electricity via steam turbine. A combined cycle power plant produces high power outputs at high efficiency up to 55% and with low emissions. In a conventional power plant, we are getting only 33% electricity and remaining 67% heat we are sending as waste. By using combined cycle power plant, we are getting 68% electricity. So it's one of the maximum utilization of waste gases, or you can say that we can get maximum work from the burnt gases descending to the atmosphere. So it's around 68% electricity can be produced with the help of combined power generation. How a combined cycle power plant produces electricity? A gas turbine. The fast spinning turbine drives a generator that converts a portion of the spinning energy into electricity. Next, the HRSG, that is nothing but what? Heat recovery steam generator, creates steam from the gas turbine exhaust heat and delivers it to the steam turbine. This steam turbine delivers additional electricity. The steam turbine sends its energy to the generator drive shaft where it is converted into additional electricity. So now we are going to see the advantages of combined power generation. The efficiency of the combined cycle plant is better or higher than the turbine cycle or steam cycle plant. The efficiency of the combined cycle power plant will be of the order of about 45 to 50 percentage. Obviously we are getting 68 percentage. What they are saying is maximum more than 50 percentage they are saying. So it is possible to get nearly 68 percentage of efficiency. Fewer moving parts and less vibration than a reciprocating engine. So it's very low toxic emissions since we are reusing that waste gases to heat the coolant water, that is we are converting that water again into superheated steam. So it emission almost loses all its heat energy and it goes to the atmosphere with very low toxic emissions and runs on a wide variety of fuels. As already I said, in gas turbine power plant, all three types of fuels will be used as the fuel: amorphous coal, CNG gases, and diesel, petrol, and kerosene. All types of fuels will be used as the fuel. So runs on a wide variety of fuels and high operating speeds. Though the speed of the turbine is more than 3000 rpm, So we are saying it's operated at high operating speeds. Next, we're going to see the disadvantages of combined power generation. Higher cost. Obviously, the cost will be higher when compared to other power plants. Next, longer startup. So the startup time will be somewhat more when compared to diesel engine power plant. Next, the less responsive to power demands. And shrill winning noise. What is shrill winning noise? That is all are rotary components, so it's going to rotate with very high speed and it's going to produce some vibration. So and also some noise. It will be called shrill winning noise. So these are the disadvantages of combined power generation. Thank you.